To learn about complementary angles. The key rule is this: complementary angles always add up to 90 degrees. So let's look at some examples to see how this works. First, let's build a right angle. A right angle is the type of angle you see in the corner of a room or a piece of paper. And a right angle always measures 90 degrees. So this entire corner we see here measures 90 degrees. Now we draw another ray inside the corner. This splits the 90-degree angle into two smaller angles. So instead of one big angle, we now have two smaller angles that sit next to each other. The first smaller angle measures 30 degrees. The second smaller angle measures 60 degrees. So when we add them together, 30 plus 60 equals 90 degrees. And since the two smaller angles add up to 90 degrees, they are called complementary angles. So anytime two angles add to 90 degrees, they are complementary. Now let's look at another example. Again, we start with a right angle, which measures 90 degrees. And again, we split it into two smaller angles. This time, both smaller angles measure 45 degrees. So when we add them, 45 plus 45 equals 90 degrees. Since these two angles also add up to 90 degrees, they are also complementary angles. Now we're going to learn about supplementary angles. This is another important idea in geometry, and it appears very often when we study lines and angle relationships. Let's look carefully at the diagram. We have 3 points labeled A, B, and C. Point B is in the middle, and it is the vertex, which means it is where the angle is formed. From point B, one ray goes toward point A, and another ray goes toward point C. Together, these two rays form a straight line. And whenever we have a straight line, the angle formed measures 180 degrees. So the angle from A through B to C, which we call angle ABC, measures 180 degrees. Let's practice solving problems using supplementary angles. Remember, angles that lie on a straight line are called supplementary angles. And supplementary angles always add up to 180 degrees. Let's start with problem 3. We see a straight line and another ray splitting that straight line into two angles. Because the angles form a straight line, they must add up to 180 degrees. One of the angles is given as 65 degrees. The other angle is labeled with the variable a, which means we need to find its measure. So we write an equation using the supplementary rule. 180 minus 65 equals 115. So the missing angle measure is 115 degrees. Now let's move to problem 4. Again, we have angles forming a straight line. So again, the angles must add to 180 degrees. This time, one angle is 128 degrees, and the other angle is labeled with the variable z, which we need to find. 180 minus 128 equals 52. So the missing angle measure is 52 degrees. And supplementary angles always add up to 180 degrees. Once you recognize straight line angles, solving these problems becomes very easy. Great work, and we'll keep building on this in the next lesson. Now we're going to learn about vertical angles. This is one of the most important angle relationships in geometry, and once you understand it, solving many angle problems becomes much easier. Vertical angles appear whenever two lines cross each other. When two lines intersect, they create 4 angles around the intersection point. Now look carefully at the angles that are directly opposite each other. These opposite angles are called vertical angles. They are not next to each other. They are across from each other. And here is the most important rule. Vertical angles are always equal. No matter how wide or narrow the lines cross, opposite angles always have the same measure. Let's look at our first example. One of the angles measures 70 degrees. The angle directly opposite it is labeled with the variable x. Since vertical angles are equal, x must also measure 70 degrees. So we conclude that x equals 70 degrees. Now let's look at another example. This time, one angle measures 120 degrees. The opposite angle is labeled with the variable y. Again, since vertical angles are equal, y must also measure 120 degrees. Whenever two lines intersect, opposite angles are called vertical angles. And vertical angles are always equal in measure. Now we're going to study something called a linear pair. This idea connects directly to what we already learned about supplementary angles and straight lines. A linear pair happens when two angles sit next to each other and form a straight line. In other words, the angles share a common side, and their outer sides form a straight line. Here we see a straight line and another ray coming out from the same point. This creates two angles right next to each other. These two angles share one side, and their other sides form a straight line. When two angles form a linear pair, their measures always add up to 180 degrees. So linear pairs are always supplementary angles. Let's look at our first example. One of the angles measures 65 degrees. The angle next to it is labeled x, meaning we need to find its measure. Because these two angles form a linear pair, they must add to 180 degrees. So we write the equation. To find x, we subtract 65 from 180. That gives us 115. Now let's try another example. This time, one angle measures 128 degrees. The angle next to it is labeled y. Again, since they form a linear pair, they must add up to 180 degrees. To solve, we subtract 128 from 180. That leaves us with 52. So the missing angle is 52 degrees. Let's summarize what we learned. A linear pair occurs when two angles sit next to each other on a straight line. And angles in a linear pair always add to 180 degrees.